Okay, welcome to this homework video. In this video, I'm going to solve problem 1 from chapter 4. Here we're asked to maximize the total number of audience members, right? So we're going to advertise via television, radio, newspaper. And then, so my choice variables here are the number of television ads, number of radio ads, and then number of newspaper ads. And from that table, they tell us that each television ad reaches 100,000 people. Radio reaches 18,000. Newspaper is 40,000. So my choice variables write the number of advertisements. So the objective function is just the sum product of these two. There we go. Okay. And then I've got some constraints. And so they give you, like the cost per advertisement, and then they tell you that, you can only have like 10 television commercials, 20 radio, and 10 newspaper. So the television ads cost $2,000 per ad, radio $300 per ad, newspaper $600 per ad, right? And that's got to be less than or equal to 18,200. Okay, so for television, I can only have 10. For radio, I can only have 20. And then for newspaper, I can only have 10. Okay, and then I have two more constraints. So if you read that below the table, if you read those two sentences, radio must not exceed 50% of the total. All right, so radio has to be less than or equal to 0.5, television plus radio plus newspaper. Okay, so if I get everything off to the left, I'm going to get something like negative 0.5. Actually, let me do it this way. Negative 0.5 television plus 0.5 radio minus 0.5 newspaper less than or equal to 0, right? Just moving all of this stuff here over. So that means this constraint is a negative 0.5, a 0.5, a negative 0.5, and then that has to be less than or equal to 0. And then the last one is television should account for at least 10%. Okay, so television has to be less than or equal, no, greater than equal, must count for at least 10%. 10% of television plus radio plus newspaper. All right, and again, I got to move all this stuff over, and if I do that, I'm going to get 0.9 for television, negative 0.1 for radio, negative 0.1 for newspaper, and that has to be greater than or equal to 0. All right, so here we go. Essentially, the problem is set up. I just need to put in, these constraints, but there you go. I've got my parameters, objective function, all of my constraints. So let's do this and then solve this. All right, so choice variables, constraint parameters, copy down. All right. Okay, so solver. The objective function, I want to maximize that by changing these three cells, subject to these constraints being less than or equal to these numbers, and then this number greater than or equal to this number. Okay, non-negativity, linear, solve, and then I'm going to get my answer and sensitivity reports for part B. Hit OK. All right, well, there you go. Here is part A. You're going to have 4 television advertisements, 14 radio, 10 newspaper, and you're going to reach 1,052,000 people. All right. So that's part A. B, how much would audience contact increase if an extra $100 were allocated to the promotional budget? So to answer part B, I have to go to my sensitivity analysis. Okay. And that is this. Here's my cost, right? So the shadow price is $51.30. So for each dollar increase in my cost or my budget, I'm going to reach an additional 51 people. Now this shadow price is good up to, I can add $13,800 to my budget and this shadow price will remain valid. Or I could reduce my budget $3,450 and this shadow price will still remain valid. So the point is, the $100 increase is within my allowable increase and decrease. So if I increase my advertising budget by $100, I will reach an additional, 5,130 people. All right. Well, there you go. There is problem 1.